Hello, today we'll do the derivation for electric potential on the axial line of a dipole. Some points for electric potential. It is depicted by the symbol V. It is a scalar quantity. V is equals to kq by r. The SI unit for the same is volt, V or joule per coulomb. So for this derivation, we'll make the diagram minus q plus q. The distance between them is 2a. We'll consider the point of observation as point P, that is at a distance r from the center of the dipole. We have considered a dipole with charge q, separation 2a, and dipole moment P, which is equals to q into 2a. We'll mark this point as A. We'll mark this point as B. This is distance A, and this is also distance A. So, electric potential due to charge at A is VA is equals to minus KQ upon R plus A. As it is a scalar quantity, we don't mention the direction. And similarly, VB is equals to KQ upon R minus A. But we do consider the sign of the charge, that is minus Q and plus Q here. So the net potential difference is VA plus VB, which is equals to minus KQ upon R plus A plus KQ upon R minus A. So taking KQ common, we get 1 upon R minus A minus 1 upon R plus A. Taking the LCM, we get R plus A minus of R minus A, so it becomes minus R plus A and R square minus A square. So R and R gets cancelled, so we are left with 2KQ A upon R square minus A square. V is equals to, as we have done in the previous derivations, 2A into Q is the dipole moment. So it becomes Kp upon R square minus A square. So the potential difference at the axial line of a dipole is Kq upon R square minus A square. And for the special case, if R is greater than A, then V becomes KQ then V becomes KQ upon R square.